Hi, in this video we're going to talk about fractions and how to reduce fractions. A fraction represents a part of a whole. There is a numerator, a denominator, and a fraction bar. The denominator represents how many total pieces of one whole we have. For example, we have a total of 3 blue rectangles here. But we don't really need all 3 of them, we only need 2. 2 out of 3. And that's what the numerator gives us. The numerator represents a part of a whole given in the denominator. A fraction bar means division. Essentially, you're taking out 2 out of 3 pieces, and 2 divided by 3 will give you a decimal or a fraction of the whole, 2/3. So 2 pieces out of 3 pieces is 2/3 of a whole. In these examples, we can see that the total of green circles that we have is 7. There are 7 circles that represent one whole, so therefore the denominator is 7. And we only need 3 of those circles. So we are going to take 3 out of 7. 3/7 is the fraction that represents 3 circles out of the total of 7 circles that are given as one whole. In this case, we have one whole represented as 7 circles, but the piece or the portion of the circles that we need is 8 circles. We don't have enough in one whole, so we need to borrow from the second set of 7 circles. So then we are going to add another circle here, which now represents a portion of the second whole of 7 circles. So this 7 means one set or one whole divided by 7 pieces, and we need 8 pieces. So we're going to take one set or one whole, which is 7 pieces, and then we're going to take another set of 7 pieces, and we're going to borrow one more piece from that second set. So then this fraction can also be given as a mixed number of 1 whole and 1/7, or 8/7 as an improper fraction. One and the same part of a whole can be represented given the number of pieces that you divide that whole into and the number of pieces that you take out. For example, I have the identical green circle in all 3 cases here, but in the first case, I am dividing it into 2 pieces and I'm only borrowing 1 piece. So there are a total of 2 pieces and I'm only taking 1 piece. In the second circle, I split it into 4 equal pieces and I'm taking 2 out of those 4. So piece number 1, and here is the second one. And in the third case, I'm splitting the same circle now into 8 equal pieces, and I'm taking 4 of those pieces out. So 1, 2, 3, and 4. Now let's see. This portion of a circle and this portion of a circle and this portion of a circle are the same portion, except in each subsequent circle we're splitting it into more equal pieces. However, we're taking the same part of a circle each time, no matter how many pieces we split it into. Therefore, we can say that these fractions are equivalent fractions, and we can reduce a fraction 4/8 to 1/2 and a fraction 2/4 to 1/2. How do we reduce a fraction? We divide it by the highest possible number that both the numerator and the denominator are divisible by. So in the case of 4/8, we can divide by 4 in both the numerator and the denominator, and we'll get 1/2. And in the case of 2/4, we'll divide by 2 in both the numerator and the denominator, and we'll get 1/2 again. It is common practice to reduce a fraction if it can be reduced. We're always trying to express our fractions in their simplest form. Here are our three circles again, and we're trying to now see how we can build equivalent fractions in this case. So in the first circle, we have 2 pieces out of how many pieces in total? 1, 2, 3. So 3 is our whole and 2 pieces is what we've taken. So let's take out piece number 1 and piece number 2. Then in the second scenario, we have our circle split into 6 equal pieces, and say we want to take the same portion of the circle as we did the first time. So here and here, how many pieces do we need to take? 1, 2, 3, and 4. 4 pieces, 4/6. And in the third scenario, we are splitting our circle into 12 equal pieces. And if we want to have the same portion taken out, then this piece here, all of this, will be represented by 8 pieces, 8/12. Now let's see, can we reduce 8/12 and 4/6 to be 2/3? So 8 and 12 can both be divided by 4. By 4 and by 4. Let's try. 8 divided by 4 is 2, and 12 divided by 4 is 3. Perfect. It is equal to 2/3. How about 4/6? 4/6, 4 can be divided by 2, and 6 can be divided by 2. By 2 and by 2. Then we get 4 divided by 2 is 2, and 6 divided by 2 is 3. And therefore, we can say that all of these fractions are equivalent because they end up representing the same portion of a circle, just given to us in a different number of smaller pieces. In general, when you are trying to reduce a fraction to its simplest form, you are dividing both the numerator and the denominator by the greatest value that they're both divisible by. So say, in this case, I can divide 35 by 5 and 45 by 5. And I will end up with 7/9. Sometimes the number that you're dividing by is not one of the prime numbers, and you have to really think about what the highest number could be. For example, you have 12/60, and I could technically divide both of these by 6 and by 6, and then it will result in 2/10. But then see, I can still continue reducing. 2 and 10 can then be reduced further by 2. and the final, the most simplest fraction ends up being 1 over 5. At the very beginning, when I was still choosing a number that I could divide my numerator and denominator by, I could have chosen 12. So sometimes we may not recognize that greatest number right away, and then you have to keep looking at your result and see if you can reduce it further. But it's definitely better to find that greatest number right away and then reduce it to the simplest form. Please like this video, visit IntoMath.org